What's up, Notjust developers? It's Friday, and that means that we are up with a new live stream, and today we're gonna learn new stuff with React Native, and specifically today we're gonna learn about animations. So, super excited about today's build. Let's have a look at what exactly is the plan for today. So today we're gonna continue our series where we're trying to build the iOS 16 lock screen with React Native. And here I've got like a lot of ideas and a lot of inspiration from iOS, specifically when it comes to animations, because the animations in iOS, they're so beautifully implemented, and everything works so smoothly. So my challenge for myself and also for you is to try to recreate these animations and see how to do them in React Native. So this is a great tutorial to learn React Native with Expo and JavaScript, and specifically for animations, we're gonna use React Native Reanimated library. So this is a great tutorial to get into that if you've been planning to start learning React Native Reanimated. So what specifically we're gonna build today? Today I prepared for you two interesting features, and the first one is a 3D parallax effect. And implementing this feature, we're gonna work a lot with the phone sensors, directly driving animations based on the position and how you rotate the phone, the physical phone in your hand. So as you will move it, the pictures and the layers will move. So it's gonna be a very beautiful effect that is quite easy to implement in your applications. After that, after we cover the 3D parallax effect, we're gonna get into the animated blur views. And this is gonna take our lock screen to a new level, just like by simply animating like the blur views when we unlock the phone, when we lock it back. That's gonna add like a little touch, but it makes a very huge difference in comparison with what we have right now. So, yes, super excited about today. Let's first have a look at what we already have. So I'm gonna do npm start, so we can see it here. Alex, I will need a bit later. Oh no, I will need a bit later the cable for my phone. All right, everything is good here. And let's run our project on iOS. Thank you. Okay, we will need that a bit later. How is it going, guys? Can we expect a Skia bootcamp? That's a very interesting question. If a lot of people will be interested, we can get into that. The thing is that I still have to get into Skia and start learning it. But I'm super excited to do that. Actually, I tried today something with Skia, but then I figured out that it's much easier to do it with another small library. And it would be an overkill just to implement the blur effect with Skia. But for other use cases, like, I'm really interested in that. So what's happening with my simulator? Doesn't want to open. Oh no, here it is. So give it like 1 minute and then we're gonna be there. Let's adjust our views here. And get ready for an epic coding session. Hopefully you can see it well. Send me your course link for Udemy. I don't have a course on Udemy. Our courses are on our own platform. And you can find it at academy.notjust.dev. So, come on. Building JavaScript. All right, so here we see our applications, and initially, like, this is how you would see the iOS lock screen, and this is actually not the iOS lock screen, this is in React Native. You can see the lock screen there, like if I scroll it down. But our application displays the time, which is the exact time based on the phone. Then we have a footer here with two buttons, with two icons, and a swipe up to open text that nicely animates, appears, as raises to the top, and then slowly fades away, which is a very beautiful animation for to attract attention to do an action. So what we also implemented is the flat list of notifications, and for the flat list of notifications we worked a lot on the animations. So there are a couple of animations here that we implemented. First animation is when we start scrolling the flat list, our footer will disappear to leave more space for the flat list. So here I'm gonna demonstrate it. If I slowly start scrolling, as you can see, the footer disappears. And when we are back on top, the footer slowly appears there. All of this, as you can see, there is very smooth. There is no jumps to this effect. So this is what I really like about it. Another thing is the way we are animating the flat list items and how they enter the screen. As you can see here on the bottom, the items are not simply coming from the bottom of the screen, but they are also changing in opacity, they're changing in size, and they're also moving a little bit in order to give this impression that the items are moving behind the flat list. So I really love these animations, how it scrolls through a list of items, and you can get this implement these animations in your application as well by following the example from the first video that we did previous week. And lastly, the last animation here is when we scroll down, our items will all move to the center and like below the screen, and we implemented them to move independently, and all of them like kind of stack together. So all of these details you can follow along in the previous episode. We're gonna leave a link somewhere at the top, and you can check it out and follow along to implement these animations. However, for today, as I said, what I wanted to do is I wanted to specifically play around with the sensor for our animations. And for that, I decided that it would be a good idea to animate the background of our screen. Sorry for that. But before we get into all of that, what I want to do is I actually want to clean up a bit our application, and specifically I want to copy this application, like all the code that we have here for our lock screen. I want to copy it into a separate component because it's going to make our coding easier today. So let's go ahead and create a new file in the components. Actually, that probably is not a component, but okay, let's leave it as a component. Should I do it like a screen? No, let's do it component. No, let's do screens. So in source, I'm gonna define screens folder, and in screens folder, I'm gonna define the lock screen.js. And here, let's move everything that we have currently in app.js. I'm gonna copy everything in our lock screen. And the only thing that we don't need here in the lock screen is, for example, this status bar, because this is what we're gonna do in our application. And other than that, everything we need here, everything is about the lock screen. And we, of course, can remove the status bar where we import it. Now back to our application. Oh, here we're gonna basically remove everything. Easier it will be to select everything, remove, and then do React Native functional export. And here, instead of this, let's render the status bar. Status bar. How was it? Style light. Let me check how is it. In our app.js, the status bar was style light, yep. And we imported it from Expo status bar, yes. Light. No, it should be dark. And inside this view as well, I'm gonna put the lock screen for now, just to see lock screen. And let's make sure to import it here. So let's import lock screen from source screens lock screen. Now it should work. None of this file exists. Yeah, because in lock screen we are importing some, for example, we are importing the wallpaper. So let's change a bit the relative path. So for example, here we're gonna need to move up 2 times. For the notification list, we're gonna move up and directly in the components. Here as well, move up and in components. And I think that's it. Okay, and the last step here for the application view. Let's define the styles for it. Styles, stylesheet.create, and container. We can start with a flex 1. And let's import stylesheet from React Native. All right, so as we can see, everything is as it was before. However, now our app.js is kind of a very clean component that we can change and play around, and is going to help us in the next steps. Okay, so I think we are ready to let me double check that. I'm gonna need to prepare some files that we're gonna need. For you, you can download the updated version of the asset bundle, and I included there the images that we will need for today's video. So I think it should be here. Okay, I have my asset bundles. For now, we're gonna start from scratch. Basically, we're gonna work independently for our effects, and after that, we're gonna see how we can integrate them in this lock screen. So for now, I'm gonna comment out the lock screen and just, I don't know, simply have here a text, or not even a text. Like let's keep it like this. Okay. And to see them in the center, align items center and justify content center. Okay, now we have a clear canvas basically where we are gonna work for our first task. Let's take them. And as I said, let me actually do the intro because we're gonna do this as a separate published video on the channel to easier find it there. So, what's up, Node.js developers? Wait, let's do this. What's up, Node.js developers? In this lesson, we're gonna learn how to implement a 3D parallax effect based on the phone sensors. And when I tell about phone sensor, here I mention about the sensor that your device has, the gyroscope, and other sensor that we have there. So we're gonna use the data, the input from them to drive animations, and in the end, we're gonna have a very beautiful 3D parallax effect for our images. So for that, let's go ahead and we're gonna start here in a blank project. For that, we're gonna start by rendering an image. So let's import the image from React Native, and also in the assets, I prepare for you a couple of images that you can download in the description below, of course. Let me grab them. For example, I'm gonna replace all my images folder with the one downloaded from below. Replace. And here in the images, I have, for example, a BG, the background picture, and some other picture that we will use throughout the tutorial. So let's import this background picture from assets, images, and the background.jpg. Now, having this image, let's go ahead and remove the text and render the image with the source background and style. We're gonna style it as image, or let's even do image. All right, now at the moment the image is very huge, but if we're gonna say that we want this image to have a width of 100% and a height of 100%, this will make sure that our image is displayed on the full screen here. All right, so what we want to do next is going to be to get the input and the data from the sensors, and then we're gonna see how to drive the animations for this image based on those inputs. So, for that, we're gonna use React Native Reanimated. So for that, we can go ahead and install React Native Reanimated in our project. And actually, there is Expo React Native Reanimated documentation that explains how to install React Native Reanimated in an Expo project. So if you have an Expo project, then let's go ahead here and copy this command npx expo install React Native Reanimated. Paste it in the terminal of your application. I already have done that, and if I check my package.json, I see that I have React Native Reanimated 2.9.1. And the next step to make sure that it's working is to add these plugins, React Native Reanimated /plugin, in our babel.config. So if I'm gonna go babel.config here, you see in the plugins I have a plugin attached. After that, restart your server. And run the application again on the device, and everything should be working fine. Now from Reanimated, let's import the whole library Animated, and also let's extract some of the things that we will need there. One of the things that we're gonna use for today's tutorial, if I'm gonna go here in the API references, we're gonna see hooks. and there is a hook use sensor, use animated sensor. So this use animated sensor, based on this, you can easily create cool interactive animation based on the data from the sensor in the device, such as the gyroscope, accelerometer, and so on. So let's go ahead and see how we can use it. Well, first of all, let's import it. Use animated sensor. And let's declare it here. So const sensor equal use animated sensor, and inside it we need to provide which sensor we are interested in. There are a couple of sensors, and all of them are stored here in the sensor type, and we can provide here the sensor. There is the accelerometer sensor, there is the gravity one, gyroscope, magnetic field, but what we're interested in is in the rotation of a device. The rotation at one specific point in time of a device, and based on the rotation, how the device is in your hand, we're gonna drive these animations. Okay, so now what we have to do, we have to define an animated style for our image that is going to be calculated every time our sensor updates. Basically every time our sensor has some new value. To define an animated style for our image, we will import use animated style. And let's go ahead and say const image style equal use animated style. And here we're going to provide a function that will calculate and return the styles that we want to set for our image. But for now, what I want to do is basically console log here. Actually, I'm going to need to remove this. I'm going to console log our sensor dot sensor dot value, or dot value, for example. All right, I'm gonna do that here, and if I'm gonna open our terminal, undefined is not an object, parent ID length. Let's see. All right, what's happening here? I'm gonna restart our server. And let's start it again. Let's reload. Use animated style has to return the style object. So let's return initially an empty object for the style, because in a moment we're gonna think how we can animate the style for this image. All right, so as we can see, we see two log boxes here. And for every event, for basically every time we're console logging, we get an object with a lot of value. These values are the pitch, the QV, QX, QY, QZ, roll, and I don't know how to pronounce this one. Basically, yaw? No idea. So basically we have 4 values. These are the 4 values that represent the rotation of a device in the quaternion way. Don't ask me what's that, because it's too complicated for my brain to comprehend. Even though like 4 or 5 years ago I was developing games, and back in that time I knew exactly how to work with these quaternions, and I knew what are they, but now I try to understand them and my head just exploded. The other 3 values, pitch, roll, and yaw, these are much easier to understand. These are basically starting with, let me... So yeah, let me go ahead and try to find roll, pitch, and it's very obvious to understand roll, pitch, and yaw based on an airplane. So the pitch acts, the yaw. My God, I need to hear how to pronounce this because I'm gonna pronounce the whole tutorial incorrectly. Yo. Let's go. I know how to pronounce it. So the axis yaw basically goes straight to the middle of the center of the Earth, and when we rotate around this axis, we are basically rotating in what direction we are facing, basically north, east, south, and so on. So rotations on this axis go from 0 to 360, and more details you can find in the documentation which one is which. So this is the first axis. The second axis is for example, the roll, and this specifies, the roll of the airplane, like how it rolls. And lastly, the pitch specifies if the plane is going upwards or downwards. So that's basically the same with your phone. We have these three axes, and the rotation of the phone is represented by them. I'm gonna go ahead and connect my phone to the computer so that we can all see how these values change, and we're gonna see how we can work with them. Give me 1 second. Most probably we will not need the simulator anymore. I mean for a bit, because we're gonna check it on the device. We need some sensor data. I have to close all the applications. And give me 1 second. Yeah, guys, how are you keeping up? Are you managing to follow along? Hey Vadim, let's build a dynamic island in React Native. I wanted to work with something related to dynamic island, but as far as I know and as far as I research, there is no simulator with dynamic island yet. There is like in beta version, so I will have to upgrade, and I was too afraid to do that before the live stream. But I'm interested in that, and as soon as there is some possibilities to work around that, we're gonna cover that because it's an interesting topic. I wanted to open an application, but I was talking and I forgot what I wanted to do. Come on. Not this one, but probably this one. So here we should have it. And I'm gonna run the Expo. Here you can see screen sharing directly from my physical device. So we're gonna be able to, for example, launch the application. And we already see a lot of numbers here. So one way we can do to decrease a bit the rate at what we receive is console logs is for the animated sensor to provide here some configs, and the config is the interval. How often should the sensor update? If we don't specify anything, it will automatically update as much as possible based on the device refresh rate. In our case, let's do, I don't know, like 4 times a second, which is every 250 milliseconds. And if I'm going to reload, it's still quite a lot. If I do 500, will you? In the config, user config, interval, number. Interval millisecond between shared value updates. Pass auto to select interval based on the device frame rate. Yeah, why you are updating so often? Oh, now it's much better. If I do 1 second, we see them at every second. All right, so in order to see and to visualize and to understand these values, let's go ahead and destructure them from our sensor.value, and we're gonna destructure all of them. So starting with the values that we are interested in, and these are your pitch and roll, and then we're gonna also actually, let's not look at the quaternion notation. Let's only focus on these 3 values. And now I want to render them like this. Then I want to render the pitch and the roll as well. But by rendering them like this, I think we don't need that many digits to understand what is happening. So I'm gonna do dot to fixed. 1 digit after the dot will be enough for us to understand what's changing when we move a phone. Okay, that's the next one. All right, here we have it. Let's have a look. Reload. It is still console logging. Oh, because it's on top. Probably. All right, now it's better. So what we see, remember the first value is your pitch and roll. Now they update every second. My phone is flat on the, okay, let me, how to do it properly, so that you can see it as well. If I put it like this, will you see it? Yes, okay. And I'm gonna zoom in here a bit so we can see it even better. Yeah, focus on the last values here, and let's have a play a bit around with the phone, and then we're gonna see. So I'm gonna having the phone with the screen upwards. I'm gonna rotate it basically around the axis that goes up. So I'm gonna rotate it like this, and as we can see, the first value here decreases until it reaches 0. And then it increases until it is back to 1.6 or something like, no, not even 1. It's even more. I think it should be up to 3.11, which is exactly P, because these values are in radians. So now we understand the first value, which is our, let's have a look, what is our first console log value? Our yaw is the direction of where the phone is looking, basically towards north, east, and so on. Now, let's start moving the phone upwards, basically the way you would look at it. So starting from here, if I'm gonna start moving it upwards, we see that the value in the middle goes to 1.6 when the phone is fully vertical like this. And if I continue rotating it, it goes to 0.20 and back to minus 1.6 when it faces down, and so on. So we see that the second value is basically the rotation of the phone. The pitch is the rotation of the phone around the axis that is horizontal. So axis horizontal, so we are moving around this horizontal axis. Now, lastly is the roll. And the roll is basically, if I'm gonna have a phone like this, the roll is the last value and it indicates how the phone is rolling on the left or on the right. So from these values, what we can understand is that we can use them to drive some animations for our image. Let's go ahead back to this scene. All right. Here we have it. Okay, but what specifically are we planning to move around? Well, basically, whenever we tilt the phone forward and we're looking from the bottom of the phone, we want to move the picture, the background picture, we want to move it a bit upwards. And when we do the opposite, we want to move it a bit downwards, and so with the other axis as well. Basically, when the roll changes, we want to move the picture either to the left or to the right, because that's how you roll the phone in your hand. So for that, what are we going to need? I think I'm gonna also draw something for you. In order for us to better understand how we are moving this picture and why it's going to be easier for me to explain some of the numbers that we have in a moment. Okay, let's hope that my PC will handle everything. New screen recording, not like this. Okay, I'm going to open it here. So I think this is better. Okay, here we have some drawings from previous time. All right, now this is better. Or I think I have it like this, no? Okay, so our device screen is this green thing. That doesn't look like a device screen, so I'm gonna do it again. This is the device screen. Device. Okay, now our picture at the moment, the way we are displaying it is basically 100% our picture. If I'm gonna do it with red, at the moment we displayed it with 100% width and 100% height. So basically it has the same width and height as our frame here. But in this case, we are not able to move this picture up and down, because whenever we will move come on, pick it. Basically, whenever we will move a picture up or down, we're gonna leave some empty space because it's not enough size. So what we have to do is actually render the image a bit bigger than our screen in order to have room for movement. So something like this, but let me... Yeah, this is our image. And by having this, we will be able to move the image up and down based on the device. So in one case, we can have Why I cannot select it? Come on. Like this? Yes. In one case, we can have an image like this, and we're not gonna see any empty white places. In our case, we can have an image move like this, and we're not gonna see any white, and so on. And also on to the left and to the right. So let's go ahead and first add this padding to the image in order to have room to work with. So for that, okay, too many devices on my table. For that, let's move back to our code. Why I cannot switch it? Stay with me, guys. Okay, moving back to our phone. Like this. So we're going to define how much do we want to offset this image. So let's define this in a variable at the top. So const image offset is going to be equal to, I don't know, 50 pixels or 100 pixels. We're going to see, and we're going to be able to adjust it as we want and as we see fit. Now, based on this image offset, I'm going to go ahead and in the styles of our image, we're going to provide here the width and the height. You know what? For that, we actually need the width and the height of our screen. So let's go ahead and import from React Native, use window dimension hook, and in our application, before we get the sensor, let's go ahead and get the width and height of our window dimension. This will give basically the width and height of our screen. Now, based on this width and height, we can give some styles to this image. So instead of providing the styles from there, I'm going to provide them right away here. So width is equal to width, height is equal to height. Now we don't need the styles here anymore. And as we can see, just by providing it like this, our image is displayed as it was before. But if we're gonna do, we want to increase the width of this image with the offset that we're gonna need for our animations. So if I'm gonna say image offset, and here as well, we're going to see that our image is actually a bit more zoomed in. And we're going to see that if I increase this to 300 pixels, right away you can see it. Another thing that I want to do is to add to our width double the amount of offset, because we have offset to the left and offset to the right, and the same thing for our height. We have offset to the top and offset to the bottom. So by adding them like this, we see that our image is actually zoomed in, and now we have space to move this image around on the screen in order to give this parallax effect. Let's see. I was working with, position absolute. Let's try position absolute. And by playing with the top position, for example, if I'm going to set top position 0, we see that the image is moved a bit to the bottom. If I'm going to say top position 100, that's even more, but top position minus 100, that's going to move to the top. Minus 200, again, more to the top. And these are the properties that we're going to use to drive the animation. Top and also left, for example, minus 200, that's going to be like this. 0, that should be like this. So if this will be our animated properties, we're gonna move them from here to our animated style for our image. So let's go ahead and provide them from here. We're gonna put them in our animated style. And the next step is to actually send this image style, which is our animated style, to our image component here. For that, we're gonna have to replace the normal image with an animated.image, because that's what we have to do in order to give some animated styles. And secondly, we're gonna provide the animated style in this array as the second property. So image style like this. And now, besides the static styles that we have here declared, we also apply these styles that are at the moment also static, but we're gonna implement them based on the pitch and the roll. Okay, so as we said, the position, moving the image to the top and to the bottom, will be driven by the pitch. So if I'm gonna do, for example, I don't know, let's say pitch, nothing will change a lot. Actually, I see something changes, but if I'm gonna multiply this by, I don't know, minus 50 or actually 50, just to play around and see what's going on here, it's not very smooth because we have this interval 1 second, and let's remove it because we are not debugging anymore. We want to see the smooth animation. And now if I'm gonna move my phone like up and down like this, we see the image is moving somehow. Now it's like this. Okay. And let's do the same thing for the left. So the left, our roll will drive it. So let's do also 50. And here, as we can see already, if I move the screen around, the image is moving as well. Well, it's not properly moving because we are just testing it out right now. And in a moment, we're going to think about how we can derive this top value based on the pitch and based on the roll. Well, for that, let's first focus on that top position. Basically, yeah, top position. Give me 1 second. I need to bring something. All right, okay. Our the pitch value the pitch value goes from negative. We can have a look at the console logs so we can see what we're talking about. So we have console log pitch is in the middle. So let's have a look at the values for our pitch. What is the range of the values? Basically, what is the minimum value and what is the maximum value? So if I'm gonna hold it like this, that's 1.5. If I'm gonna hold it like this, that's basically 0. If I'm gonna go there, that's minus 1.5 somewhere there, or actually 6, yeah, 6. So as we can see, the values go from minus 1.6 to plus 1.6. And this 1.6 is not a random value. This is half of p. Basically, it's the angle in radians. So 1.6 is p over 2. Okay, so what we need to do is to somehow get the top value based on the pitch, knowing the range of the values that the pitch has. So for that, we're going to use the interpolate function. So we're going to interpolate based on the pitch. First, we need the input range. And as I said, the input range of a pitch goes from minus p over 2 till p over 2. So I can have it here actually, const. Let's do const p. I'm going to take it from the math.p. Let's do half p equal p over 2. And yeah, this way it's going to be easier for us to understand here. So as I said, our pitch goes from minus half p or pi? Yeah, pi, sorry guys. And it goes to all the way to half pi. Okay, these are the input values. Our output values will be what range should top move in. Yeah, in what range should our top value move? Basically from what value minimum to what value maximum. If we're gonna play around like directly here with the top position, so if top is 0, that means that, let me unlock my phone. I need to reload. So if top is 0, everything is okay. If top is negative, I don't know, 100, the picture moves to the top. If it's negative minus 200, the offset is too much. The offset, yeah, let's put the offset 100, so it's going to be easier for us to understand. Offset is 100. So if we move 200 pixels, that's going to be maximum how much the picture can move up, because if I add 20 more pixels, then we're going to see the white at the bottom. So that means that top goes from minus 200, which is 2 times more than our image offset. All right, let's put it here. Image offset multiplied by 2, and that's minus. So from minus that till, let's also manually have a look at the maximum top value that we can give. Probably that's going to be 200. No, 200 is too much. Actually, it's going to be 0, because when it's 0, it's all the way to the top. If it's already 10, that's already moved to the bottom. So maximum value will be 0. All right, so that means that the maximum value is 0 here. And now however I'm gonna move my phone in the hand, the image will always be visible, because we properly matched the pitch input range to our image offset, basically the image top position offset. Okay. So now if I hold the phone like this, or I'm gonna do it for you, and if I move it a bit to below, you can see how the image basically moves to the top, and it gives you the feeling that you're looking from the below of the image. I can increase this simply by increasing the image offset here to 200. And this is gonna be like way more movement. So like this, hop, hop. Hopefully you can see it. So let's do the same for our left position. Our left position is going to be an interpolation based on the roll. The input range for the roll is actually not half pi, but a full pi. Yes. So pi, I mean from minus pi to to simplify, and the ranges that we want to do is going to actually be the same as here. Now, if I'm going to move my phone to the, if I'm going to roll the phone where the image moves in the same direction, if I'm going to roll the phone here, the image also moves. So now we have this beautiful parallax effect, and the way we are moving, the picture moves here on the screen. If you want to test it on your own device, I can actually run it right now so you can have a look in your hand at how this actually works. Do you want that? All right, so in the hand, like, it really looks very beautiful. Another thing that we can do is to smooth up a bit the animations, because at the moment our values are directly dependent on the sensor values like pitch and roll, and we sometimes can make the animation look not as smooth if, for example, the sensor values glitches, or I don't know, it changes too fast. For example, there is one moment when our axes change, so in that situation, like, it doesn't look very beautiful. What we can do is to put a timing animation on top of this value, and that will make sure that we slowly move in the desired direction, not directly. So for that, we have a but with timing value. So let's go ahead and wrap our interpolation in with timing. And what this will do is it will move the top position towards the desired position, this one, but it will move in an interval of time, basically slowly over time, frame by frame. And by default, the time is 300 milliseconds, but for us, that's too much. So we can adjust it here in the configurations, and we're gonna use a duration of only 100 milliseconds. And let's do the same for the second interpolation with timing, and the configuration here, duration is 100, just like that. And now if I'm gonna reload my application, come on. Yeah, now our animations, as you can see, are a bit more smoother, and if we like move the phone a lot around, like, the animation will not jump from place to place as it used to be. Now it slowly goes in the desired direction. For demonstration purposes, 200 is good, but I think for actually, like, in the hand, it feels much better when this effect is not that, like, obvious. It's very small, and 100 or even 50 can work well. All right, so what is the next step? The next step, let's actually create a component out of this and move it into its separate component, because that's going to help us for the next step. And the next step is even better than this one. So what I want to do is, in the source components, let's go ahead and create a new file for our new component, and let's call it sensor animated image.js, sensor animated image. Let's copy everything from the application. because it's going to be easier for us just to remove what we don't need. For example, we don't need the status bar, we don't need probably this view, and also we don't need this container. We don't need these styles. And let's see what don't we need from here. For example, status bar and a lot of components here. Yeah. Now it's much better. Let's rename this from application to sensor. Sensor animated image, and let's export it like this. Now in our app.js, instead of rendering this image, let's simply render the sensor animated image like this. In the sensor animated image, instead of rendering the image that we import here, let's go ahead and actually receive this image in properties, because it's going to make this component much more flexible, so we can send any images and it will animate the way we want it. So let's do image here. We're gonna receive it for properties as image, and let's render it here in the source as image. So for that reason, we don't need the background import here anymore. But from app.js, what we have to do is to send here to the sensor animated image, the image which is background. Yeah, my computer started. Yeah, like this. And now let's go ahead and from app.js, we don't need any more the animated style, the sensor, the height, the width. Basically, our application is back to a very small and clean component like this. Not even this. I think it should be like this. Save. I see Mateus is following along. Oh, that's nice. Have you ever used Moti for animations? No, I haven't used Moti, but I really want to give it a try as well. There's so many things that they want to give a try, but there is not enough time in the day. Sensor animated image. Yeah, we need to import it. So let's go import sensor animated image from source, components, sensor animated image. Save. Now, what's going on? Here, everything good. All right, so we are back to what we had before, and that's good. But the good thing is that now our image is in the sensor animated image, and we're gonna be able to use it in the next tutorial to implement a 3D multi-layer parallax effect, which will take this tutorial to the next level. So I think for guys, don't worry, the live stream is still going. I'm gonna really quick do the outro for our video, and then we're gonna move to the next part. All right, guys. So in this tutorial, we learn how to build a sensor-based parallax effect for an image. And in the next tutorial, we're gonna take this to the next level, and we're gonna implement a multi-layer 3D effect with a parallax effect based also on the sensor values. So I'm gonna leave a link somewhere here on top. Check out the next tutorial as well. If you enjoyed this, like, subscribe, and all the good stuff. Okay, so guys, everyone who is live here, let's go ahead and move on to the next step. Before that, let me actually remove a console log from here. We don't need the yo. And I think we can go ahead and do git add, git status, animated sensor animated image. Sensor animated image. All right, so the next step, as I said, come on. Oh my God, my CPU is burning. So, are we ready? Are we ready? What's up, notjust developers? In this tutorial, we're gonna learn how to build a 3D parallax effect with a multi-layered image. For that, we're gonna use our sensor animated image component that we built in the previous video, so you can check it out somewhere here. I'm gonna leave a link for that. And today we're gonna put this to the next level and make this multi-layer animation. So let's get started. For that, what we will have to do? For that, I already prepared some assets, and you can also download them from the description below. And here in the images, we have a folder called Parallax. I have created a simple image in Canva that has a lot of elements. I can reveal it in Finder. Probably it's gonna look a bit better that way. This is the image. It has a lot of elements, and then what I did is I actually split it into multiple layers, and I left like some of these elements on different layers. And all of these layers, as we can see, come on. We can see them in the second picture. Come on. No, that's impossible. Probably I'm gonna upgrade my MacBook. I really didn't want it to do that, but I think I have to. It's impossible. So as we can see, as I said, our image that we have created, I split it into multiple layers, and that will allow us to animate each individual layer at its own, and this will give us this cool parallax effect where it will give us the feeling that every layer is a different distance from the screen, and they will move with different speeds. So it's gonna be a very beautiful animations in the end. So we're gonna use the sensor animated image that we have created in the previous component, and this image actually works based on the sensor of a device, on the gyroscope and other sensors. As we move the screen, our image also moves there, as we roll the screen, as we tilt the screen, and so on. So this will also power our 3D parallax multi-layer animation. So what do we have to do? First of all, let's go ahead and create these components right from the beginning. And I'm gonna create a new file here. I don't know, let's call parallax.gx. And let's define it here, React Native functional export. Now, this parallax, we will receive an array of images and basically an array of layers, right? Every layer that we need to render on the screen. So let's go ahead in our app.js and import parallax from components. And also we have to import every single layer for our parallax component. So from the assets, we're gonna have to import layer 1, let me save you some time and some nerves for me. And I'm gonna import layer 1, that is the parallax2.png, layer 2, which is the next image, and so on until we imported all 4 layers for our parallax effect. Now let's go ahead and render this parallax effect instead of our sensor animated image, and we're gonna render it like this, parallax. And as we said, we want to send all of these layers through properties to our parallax. We're gonna send it as an array, and we're gonna start by from layer 1 all the way till layer 2, layer 3, and lastly layer 4. Okay, we have we see on the screen the word parallax, because if we look here, that's what we are rendering here, parallax. All right. But what do we have to render there? Give me 1 second to find some of the pictures and the thing is that we don't need any view here, so we're gonna leave this empty fragment, and let's go ahead and map through all the layers, and for every layer, let's map, and for every layer that we have, we are gonna render a sensor animated image. So let's go ahead and render that sensor animated image. And the sensor animated image expects a property called image. So the image will be our layer that we want to render, like this. And we need to close this tag right away. Okay, we see all the layers on top of each other. One of the problems is that we see here a warning, each child should have a unique key. So for that, let's grab the index of this layer, and I'm gonna provide a key that is created like layer underscore index. And this way, all our layers will have a unique key index. Now the warning is gone, but the problem is that if we look in our assets, parallax, basically image.2.2 PNG is the first layer that we need to see on top, basically this with React logo. But the problem is that everything is inverted and we see the last layer on the top. And this is because in app.js, that's the order we send them in, the first layer, the second, the third, and the fourth. But when we are rendering, we actually want to reverse the order to start rendering them from the last layer and all the way till the first layer, in order, to have the proper order that we expect. To invert a list of to reverse an array in JavaScript is very easy. We just provide here reverse to the layers before mapping, and that will switch the order of rendering these sensor animated images. And now if I'm gonna move my phone, all of this layer moves. But it's not right what we expected it to be, because we want every single layer to move with different speeds, right? So how do we do that? Well, the layer in front should move probably the fastest, because we are it gives this impression that we are close to it. So basically the same as with a camera, like if we're gonna move with a camera, the objects that are close to you, they will, on your screen, they will move very fast, and the objects far away, they will move very slowly, and this will give this depth effect. So let's go ahead and send to the sensor animated image a property here called probably layer, or not even layer, I don't know, index or distance, how far it is. I don't know, let's go with a layer. And the layer will be our index. And let's actually do index +1 in order to give layer 1, layer 2, layer 3, and so on. Let's go back in our sensor animated image and let's receive this layer. Layer actually is a very bad name. So I don't know, let's give an index here, or position, index, distance. So many distance. Distance 1. Order. Which order is this image? Okay, order, very bad still. But I'm gonna go with it because I cannot figure a better name at this moment. So having the order, what we can do is we can decide how much we are moving to the top and how much we are moving to the left, our each individual layer there. So what we want to do is we're not going to touch the input range because the input range doesn't change, it's the same. What we're going to touch is the output range, basically how much we want to move. And what we're going to do, let's try to divide this by our order. Image offset divided by order. I think it's image offset multiplied by 2 and then divided by order. Is it correct? I don't know. We can try. Divided by order here as well for the left. And now if I'm gonna reload, let's open it up. And now, as we can see, yes, all of them are moving with different speed. You can have a look at, for example, the circle and this triangle, and you can see that they all move with different speed. All right, another thing that I will do in order to improve a bit the way it looks, but this one depends on how you want this to work. The thing is that now the layer that is far away, basically the last layer in our array, it will move very slightly. It will never move all 100 pixels to the left or to the right because we are dividing this number by the order. So we are unnecessarily leaving too much space for too much offset for those layers, which is not actually what we want to do. So let's go ahead and do width plus this one divided by layer, not layer but order. And let's do the same here, divided by order. And now our components to the bottom, they know that they don't need a lot of space to move, so they will leave only the right amount of space for them. And now when I move, like we can see that everything is so smooth and nice. They're moving on the screen, all layers with their own speed. So, what do you think about this, guys? I think that's everything for this parallax animation. Let me put it here so we can have a look in the center. So in this video, we will build this 3D parallax effect that I have here in my hand. And as we move the screen, we see that our background moves, and the effect that gives this effect is the multi-layer parallax effect. Basically, every layer that we have in this image, we are moving with different speed, and this gives us the effect that the animation is like all the elements are a different distance from our screen. Okay. Come on, where is my mouse? All right, let's put it back here. Let me check in the hand if it actually does what I expect it to do. Yeah, it's so nice. Try it yourself. I'm gonna give probably I can give you access to that. npm start and what tunnel I think is called. Tunnel connected. So now if you scan this QR code here, you're going to be able to run this application in your Expo Go application. So if you have Expo Go on your device, you can now go ahead and scan this QR code with your phone and to see the animation in your hand that we just built there. I really like these animations. It would look so beautiful, like if you add like small elements with this parallax effect on some splash screens or on some login screens, on some screens that like otherwise would feel empty. So these small details like add a lot of effect to your application. All right, I see that someone is trying to run it on Android. I really wonder how it works because I haven't tested it on Android. Can you let me know if everything is okay on Android as well? Because on Android, we might have to ask for permissions for these sensors. That's not it, guys. We're gonna take like a small break. We can have a talk in the chat. But the next step would be to work to implement this in our iOS screen, and also to implement some additional features in our iOS lock screen that I have prepared for you today. For example, one of the features that we're gonna implement today is the blur background. Like as you can see, this is the actually iOS lock screen, and when we try to lock our phone, we see a blur behind this lock screen. As the more we move, the less of the background we see and the more of the lock screen we see. And yeah, like this is a really nice animation that we will do it in this video. Andrew Luca, hey Vadim, watched last night your last recordings. I can say for sure now that I understand React Native. Thanks a lot. Oh my God, that's so nice. Thank you very much, Andrew, for watching this. And if I'm not mistaken, you're from Moldova, right? Salut, salut. Okay. People that are testing this on Android, let me know. Is it working on Android as well? So I think we can move on to the next tab. This one is done. Let me go ahead and commit everything. This is gonna be our multi-layer parallax effect. And we can go ahead and we can go back to our lock screen, because we're going to continue with some things on the lock screen today. So let me go ahead and import lock screen from source screens and then lock screen. And now I'm not gonna render the parallax. Actually, I'm gonna render the lock screen. I wanted to render the parallax on lock screen, but that's gonna be a bit distracting. So let me go ahead and actually close my phone here and simply run back on an iOS on a simulator, so that you can properly see it on the screen, and hopefully it's gonna be easier for my PC. Damir, hello. Привет, привет. How is everything going on there? So, application is running on the simulator. All those animations look so cool, but sometimes it's difficult to find a proper use case for it. Did you use a lot of animation for startup? That's the thing. Basically, whenever you're building startups, you rarely need animations. Like as long as you haven't reached like a product market fit, animations will never be on your top priority list, or at least they should not be on your top priority list, because there are so many more important features that you can focus on building to provide real value to the people besides animation, or at least this is what I think. And for that reason, like for a long time, I haven't worked a lot with animations, only with some simple animations. But lately, I've been inspired by a lot of like cool animations, and I've been curious, like, okay, like how can I do that in React Native? And let's give it a try. So this is my experience learning animations and sharing this with you. So I'm no close to an expert in React Native animations. But this is a really fun experience, and I really enjoy thinking about them, because it involves also a lot of math. It involves a lot of like geometry, sometimes like very complex things that I really forgot from my school or university, and I just have to get back into those details. Like this week, I was researching quaternions, trying to wrap my hand around them and trying to understand if I can use them to drive some animations. And in the end, I haven't properly understood them like until the end, the way to explain them to you. But that's not the end. I still I have like a very quite big project in mind that would be really excited to build in React Native, and specifically around sensors, but there it will imply way more calculations and way more work with angles, with quaternions and so on. My idea with the application that I'm thinking to build, like that would be probably the exam for myself, like if I properly understand animations and angles and so on, is to build kind of an AR sky scanner. Basically, there are a lot of applications on the phone that you can point on the sky and it tells you what stars there are. I'm thinking to use like some kind of an API for satellites. and to display your satellites are around you at this moment. So in that situation, like probably that's the complicated part, but I will see if I will manage to do it. So keep me accountable. Ask me in a couple of weeks what's going on with our sky scanner, and we can do that. But yeah, this is my opinion about animations. Can we develop Uber clone dashboard side, please? We have a tutorial on the Uber Eats dashboard side. You can have a look at that. For the Uber clone, yeah, maybe we can do that. Oh, some Fire content coming up. I don't know if I'm gonna manage to do that. That's challenging, that's complicated, I'm not gonna lie. But there will be a lot of Fire content coming up, guys. We're like just starting. We're gonna focus a lot on producing content tutorials for you guys. So if you enjoy watching this channel, make sure to subscribe to down below, because more than 98% of you are not subscribed. You're watching everything, but you're not subscribed. So not sure if that's very nice, but I really, really appreciate if you support this channel and support our work. That's a really nice live stream. Like, I really like, probably I will do more live streams like this, where the focus will be on the edited videos that we will produce later. And this way I don't feel the pressure of always moving. I can stop and I can talk with the live chat. So yeah, it's really nice to exchange ideas with you guys. But now I think we can move on. And as I said, what's going on here with our lock screen container probably needs a width. And I'm going to close my server in order to start it without the tunnel. Let's run it on iOS. What's going on with our lock screen? Lock screen, we have here style container with, yeah, now it's better. It depends how we put it, but yeah. All right, so our lock screen is here. So what I want to do is I want to start working with blurred views. And why do we need them? Well, first of all, when I was preparing this application, I used a transparent view for the background of our notification icon. But if we look at the notifications, I don't have them here, on the iOS, the background is not transparent. The background is actually blurred. So it might feel like not a big of a difference, but when we will implement it, you'll understand that it's actually a big difference when the background is transparent and we see like these very clear shapes in the background, for example, here around the circles and so on. But when the background is blurred, like it looks much better. And even though like we have the same kind of color, everything that is behind is less visible. So it makes a lot of sense to implement this for our notification items first, but then we're gonna take it a step further and implement it also to animate how we are locking and unlocking the phone. So as you can see, this blurred view is actually animated, and it depends on how far are we swiping up, how far are we swiping down. So this is what we're gonna do in this lesson, and without further ado, we can get started. For that, we're gonna use a library called Expo blurred view. Expo blur view. Here is the documentation for this, and everything that we have to do here is to install Expo blur in our project here. Let's go ahead and install it. And after that, let's go ahead in our components and let's open the notification item. We're gonna start with this notification item to implement the blur view. And if we look into the documentation, the way this blur view works is we wrapped some content with this blur view, and everything behind this blur view will be blurred. So this is the important thing because it might be confusing. You might expect that everything inside the blur view is blurred, but this is actually working our way around. Everything that is behind this component is going to be blurred. So let's go ahead and import blur view here. Let's import blur view from Expo blur. And what can we do with blur view? Well, we need to probably wrap our everything inside this container in a blur view. So let's put the blur view here. Let's close it at the end before basically before closing the animated view. And by doing that, we already have something, not exactly what we want to, but we're gonna get there. The property that blur view expects is intensity, and it goes from 0 all the way up to 100. And depending on that, like the intensity of a blur. Now, it also expects a style, and the style, I think we can move the style for the container from the animated to here. Yes, that's good, but we lost the round corners. So our round corners, we can add one more property to the container, overflow hidden, and this will make sure that our round corners are still there. And as you can see, our background of these items is blurred. So it's way different than it was before, because if I'm gonna put here 0, you're gonna see how we had it before. So this is a transparent background, and this is a blurred background. And also probably we can play also with background color like this. Okay. There is another property for the blur view, the tint, and tint can have 3 values: dark, default, or light. For example, a dark tint will look something like this, and I think that's what we intend, what we are looking for. A light tint will be, like this, and probably a light tint will work well when the background probably is white, but for us dark is okay. So that's how simple it is to work with this blur view. The thing is that on iOS, it will actually render a native blur view component because iOS has this native blur view. But on Android, because Android doesn't have like such a native component, on Android, this will render with transparency. So if on Android, don't expect this to work as it is working in iOS. But it will still look good because it has like that transparency. So we fall back to what we have natively on the platform. So that's regarding our notification item. Our next step is going to be locking and unlocking the screen. And for that, we're gonna use a gesture handler, and then we're gonna drive the blur intensity based on the how far are we from closing or opening the screen. All right. So, okay. Notification item. All right. Let's go ahead and I'm going to commit everything. Okay, so in this tutorial, we're gonna learn how to implement, in this tutorial, actually, we're gonna learn how to use the gesture handler in order to drive some animations. And we're gonna do that specifically in our iOS lock screen project in order to implement unlocking the phone basically whenever we swipe up. At the moment, nothing happens, but what we want to do is to actually have this nice swipe up to unlock the device animation that will be driven by the gesture of the user. So let's see how we can do that. Well, for that, we're gonna use gesture handler together with Reanimated. So if we go into the Reanimated documentation, we have here a use animator gesture handler. But for that to work, we first need to install and configure gesture handler in our project. So let's open this URL and let's go ahead to the installation guide to in an Expo. Yeah, basically I will do it myself. So let's go in our project and do npx expo install React Native gesture handler. Is this the only step? Yeah, I think no. The next step would be to wrap our application in a gesture handler root view. So let's go ahead in our app.js and we're going to import here at the top, import from React Native gesture handler. We're going to import the gesture handler root view. This one. This component, we always need to wrap our application with it in order for our application to properly manage the gesture handler. So we can actually replace this view with our gesture handler root view because it also supports the style. It extends a view and it supports the style. So now everything is okay. Everything is prepared for the next step. Our next step is going to be where? Going back to our Reanimated, we're going to use the use animated gesture handler in order to drive some animation for our objects, for our gestures. Yeah. So first of all, we are going to have to define the area where we want to handle the gestures. And we cannot define the whole screen as the gesture handler because, for example, in the middle of the screen, if we scroll, we want to scroll the list. This part is regarding scrolling the list. What we can do is to define here on the bottom like a small part of a screen that will actually handle these gestures of unlocking the phone. And this actually happens on the iOS screen as well, because here in the middle, if we scroll, we are not unlocking the phone, but if we start scrolling from the bottom here, then we are actually unlocking the phone. So let's go ahead in our lock screen, and we're gonna import a component from gesture handler, which is called pan gesture handler, or part, how's it called? Yeah, pan gesture handler from React Native gesture handler. So many hard words for me today. All right, so using this component is going to help us detect pan gestures, basically drags over the screen. So let's go ahead and render it somewhere on the bottom of the screen for the lock screen. Where? Probably I'm gonna do it like right after the swipe up to open. Let's go ahead and render the pan gesture handler, and we can, okay, 1 second. And inside the pan gesture handler, we need to render an animated view that we are gonna give some styles. For example, let's give right away a background color red, just to see where this component is displayed. Another thing that I want to do is to display it as absolute. So I'm gonna say position absolute, like this. And what else? I want the width to be full width of the screen, and for the height, I want around 100 pixels, something like this. And it's not positioned where I specifically want it to be positioned, but I can provide here bottom 0 and left 0. Okay, why is it not? Do you know why it's here? I don't know. Let me actually try to move it outside of our footer. This is our footer, right? Yeah, this is our footer. So I'm gonna move it outside of our footer. Like this. And now it actually displays properly where we want it to be. Don't bother about the background color red, because once we are done, we will uncomment this out and we will not see this this view, but it will be there and it will be ready to handle our pan gestures. So I'm gonna leave it with red just for us to at least see it on the screen and understand what's happening there. Okay, so now let's define the handler for our pan gesture handler. That will be the place where we will write our logic. So for that, we're gonna use the use gesture handler hook from React Reanimated. I don't see React Reanimated here, but it's here, animated. So we need the use animated gesture handler, and let's define it here. Const swipe, or let's call it, I don't know, unlock gesture handler equal use animated gesture handler, and here we need to specify the an object with our events that we want to handle. There are a couple of events. One of them is, for example, one start. Basically, whenever we start the gesture, we have on active, and this is whenever we are we keep like dragging through the screen. This will always be called. And lastly, we have on end that will be called when we end our gesture. So let's go ahead and start with some console log on start. Let's do the same for the other, just to see on active, and here on end. Now this unlock gesture handler we can send to our pan gesture handler as handle, or on gesture event unlock gesture handler. Now let's look at our logs, and let's start dragging, starting from the red area. So if I'm gonna start from somewhere else, I don't see anything, but if I'm gonna start from here, error, unsupported top level event, type state change dispatched. Unsupported top level event. What's going on here? Maybe I need to, most probably I have to restart the application. Let's try that solution first. And let's start it with clear. Come on. Whoa. What's going on there? That's not how it's supposed to look. And now, oh my God, looks so bad. Why is distorted? And yes, on active, on end, and when we start, we see on start, then on active, as long as we are dragging, and then on end. The cool thing is that all of these events contain, they contain some information. For example, we will receive them here in the event. So in the on active, if I'm going to console log the event, we're gonna see what information we know about the drag event. So if I'm gonna do like this is the object, and we see a lot of things like absolute X, absolute Y, the event name. What we are interested in actually is the translation Y, and we specify how much did we move a finger on the Y axis, and there is also translation X, which in this situation we are not interested in, but in our situation we also need it because this indicates how far did we move our finger on the X axis. So based on this translation Y, let's go ahead and save this translation Y in a shared value, because this translation Y will drive a lot of animations. For example, as we move our finger up, we also need to move the whole lock screen and reveal the home screen underneath, right? So let's go ahead and have here a used, let's do const Y. I'm gonna do just Y. Use shared value. Initially is going to be 0. Now let's go ahead and in the on active, we're gonna say y.value equal to event.translate translation y. And yeah, at the moment nothing will change, but based on this y value, we can move a bit this container. For example, if I'm going to manually add this container is, if I'm gonna to manually add a transform translate y, for example 100, then we're gonna see how our screen moves below. But if I'm gonna do minus 100, it's gonna move in that direction, upwards. So this is the property that we want to animate based on our y value that we get from the gesture handler, from the finger of the person. So for that, we're going to have an animated style, similar to how we had it for the footer, but in this case is for our whole container. So container, animated container style, use animated style, and here we need to provide a function that will create this style. So as we said, we want to animate the transform, and specifically the translate y, using the value from our shared value y, like this. And here we should have an object, not like this. Now let's go ahead and send this animated container style to our image background. But we need to check if animated contains if animated contains the image background property. I don't think it does. I don't think it does. So for that reason, we're gonna move a bit of things around. For example, we're going to wrap our whole component in a view, in an animated view, like this. Oh my god, let's close it at the end, so that our image background will be a child of our animated view. It's still, what's going on there? Okay, something is showing up. I don't need that transform here anymore. I'm gonna leave it styles.container. What's going on here? Let's do here styles.container. And here we don't need styles.container. Or maybe we need. Container, what does it specify? Flex 1 and width 100. Yeah, let's do it like this. But for the animated view here, we also want to send the animated container style that will move up and down our component as we drag the finger on the screen. So let's add here the animated container style, and let's give it a try. If I drag from here and move up, as we can see right away, our animations are working. Okay, that's perfect. So that means that we're on the right track. One thing to smoothen up the animation is not to, for the style of our container, not to move it directly proportional with how our finger is moving, but to use that timing animation in order to do these changes through a small period of time, and that will improve the smoothness of this animation. So it's going to be very easy. For example, the translate y will be with timing. We'll try to follow the y value. With timing, we need to import it from Reanimated. And now, as you can see, like, okay, probably we can play around with play a bit with it, specifically with the easing, or with a duration of 100. Let me actually check on iOS. Does it actually? Don't like it very much, to be honest. I think it's because of easing, but I didn't have time to learn a lot about easing. It's the way our timing function works. So there are different easing functions, and I'm gonna look here, easing functions, just to show you what I mean by that. And the standard easing, I think, is in out, something like this, where open image. Yeah, the default should be something like this one, is in outside, where we slowly start, then we accelerate, and then slowly end. What I'm interested in is something actually linear. Do we have something like linear easing? Let's have a look. Easing. Easing. See. Where is my with timing? Here, with timing, and the easing will be easing dot linear. There is a linear. Yeah, now it looks much better. Yeah, I think that's what I needed, a linear easing function for our timing animation, so that it doesn't change like very weirdly throughout the animation. It slowly moves towards the finger. Okay, so our view is actually following the way we move on the screen, but the problem is that, as you can see, it kind of stucks in the middle whenever we leave a finger. So what we have to do is on end, for example, we can right away say dot value equal 0, and that will make sure that when we end, it will move back down. But we don't always want to move the screen down, because if it's more than halfway to the top, it actually should go up and unlock the screen. So we're going to have to do some checks. If y.value, if current y.value is more than half of a screen, half of a screen, do we have a height? We don't have a height. Let's get the height of a screen. Height using use dimensions. So we're going to check if y is less than height, is more than height divided by 2. Then what we want to do is actually we want to go to the position height, and vice versa, else we want to go to the 0. So now if it's here, it's gonna go to the 0. If it's here, it's gonna go also to the 0. I think I know why, because our y.value is a negative value, if I'm not mistaken. If I'm gonna do that, we see it's a negative value. So we should do it a bit different. If the negative value is less than minus height divided by 2, then okay, then I need to move to the minus height as well. So I'm gonna refresh. If it's not enough, it's gonna go back. If it's all the way to the top, and if I release it here, now I see it go to the top. That's actually what we wanted. By the way, let me know if there is a way to enable some kind of a way for you to see my interactions. I'm gonna quickly Google it. iOS simulator. Show touches. Will it actually work? Should I try? Let's give it a try. And I should restart my emulator. And start it again. Yes, now you can see it better. And yeah, as I said, it works as we wanted. Another thing that I want to implement right now is, the thing is that if I very fast move it up, it should always unlock it, not only when I reach the top. So for that, we're gonna have to work also with the velocity of our movements. So if I check here, instead of, let's get the event when we end this gesture, and let's console log event dot velocity on the y-axis. Now, if I'm gonna slowly move up and then release it, my velocity is minus 83 pixels. If I'm gonna do it very fast, my velocity is 900 here. And if I'm gonna do it even faster, my velocity is 3000 here. So we need to, here is where we are unlocking, unlock. And here is where we reset. So if our velocity is less than minus some number, minus 500 or something like that, then we want to actually unlock our phone without checking these field values. So we're gonna add here a OR operator. So if the velocity y is less than minus 500, then we want to unlock it. And now if I'm gonna slowly move up and release it, it's gonna come back. But if I'm gonna do it fast, then it's gonna unlock it. So that's how we implement this event. Maybe it's too fast, right? If it's too fast, then we can also slowly move to that direction. For example, here we can do with timing to minus height based on some duration. For example, the duration to this would be, I don't know, 500 milliseconds. And maybe the default 300 will work better. And as well, we can provide the easing as easing.linear. Okay, and the same thing for the, I think when we go to 0 is okay, or is too fast. Let me see on iOS. No, it's too fast. So we're gonna do with timing here as well. Okay, now it looks better. All right, so that's how we implement this gesture handler here. What we also can do is in our application, go ahead and render the actual home screen. It's gonna be like a simple like image. I'm not gonna develop the home screen of iOS, but it's gonna give us this impression that we are unlocking the screen. So let's go ahead in the images, and we have here home or home 2. Let's import them. Home. I think I'm gonna import home 2 because it has a better quality. Assets, images, home 2.jpg, and I'm gonna render it somewhere here. I don't know. Image, source, home 2, style. Let's close the image and let's see if we have it. We need to probably import the image from React Native. And here is the image. If I refresh, the image is displayed on top of a lock screen. If I'm gonna do it like this, our lock screen is displayed on top of the image. And if I swipe up, we see that we have a unlocking effect. Probably we should also do like locking the screen from here. Actually not sure about that, but yeah, maybe we can do that a bit later. Now let's go in the lock screen and remove this red background color from this view. And also I think I'm gonna replace it with our with a style here called gesture container. And let's copy all the styles from there. Styles gesture container. Now, yeah, I think it looks good. We don't have the red, but our component is still working as expected, and we can unlock the screen as we want. This is already the iOS lock screen. Let me think before moving on if I really want to implement the dragging from the top to get the lock screen as well. I think we can do that, but we're gonna do this in the app here. Or you know what? I'm gonna render this image inside our lock screen just to have everything there in the lock screen and not work in the application. So let's grab this image from here and move it in the lock screen somewhere on top. Probably we're gonna put it here. First, we're gonna put the image, and then we're gonna have an animated view. And yeah, like here we have a lock screen, basically, and here we have the home screen. We need to import the image. We need to import home too in our lock screen. And yeah, now it works better. It works the same, but the thing is that our home screen is here, so it's gonna make a little bit easier to implement the gesture that will unlock the screen. So the gesture that will actually lock the screen is moving from the top, like from the top part, from the very top. Yeah. What do we do? What do we do here? Should we make this a background image? Let's try image background, because inside of it we need something. For example, we need another punch gesture that we have similar here for locking. Let's do it like this. So for this one, I'm going to do color, background color red, or let's do blue. And it's also on the bottom, right? Yeah. Punch gesture container unlock. There will be unlock and lock. So this one will be container unlock. And we're gonna have a same, almost the same for the lock. Position absolute. We're gonna not put it on the bottom, but on the top of the screen. Same height, and also let's do background color just to see it. Background color blue. Now it's here on the top, and let's go ahead and we specified the same gesture handler. And I think the same gesture handler should work for us. Kinda, but not exactly. I think we're gonna have to also work with the event console.log event dot let's just do event, and let's have a look. If I do it like this, hey, on active. Console log, come on. What am I doing wrong? This one has on active, but the other one doesn't. Weird. Nonetheless, from this one, let me put it here. What do we have? We have a lot of things. Absolute X, absolute Y. Translation. But also there should be absolute y. What's gonna happen with absolute y as we move it to the top? As we move it to the top, our absolute y, 210, 211, decreases. Maybe we need it with absolute y. Let's give it a try. So on active, I don't know why the console log here doesn't work, but absolute y, not exactly, not exactly. We need the starting position, and then we will add the translation. So on active, I don't understand why. Oh, because I think it moves from there. Wait, you know what we can do? That would be a bit tricky, but in my opinion might work. Is instead of having two of this gesture handler, only to have one here on the bottom, this one. So for the unlock, it might work, you know. Background color red, and if we make it like that, this with this span gesture container expands a bit to the bottom of a container. With a transform translate -100. Are we working? Yeah, with other one, with this one. Transform y 100. It's the height is 100, so let's make the height 200. And now this this red will be half there, half here, and we will be able to work with only one of them, I think. So I'm just gonna comment out the blue container from here. And we're gonna figure out how to work with this one in order to so we have this on active. On active doesn't have but on start has the starting coordinates. So on start console log event, let me comment out it from here. And now when I start, come on, absolute x, event name, handler, number of points, all state, state, target, translation, velocity, x and y. It has x and y. So we can use the x and y from there. Why not to use the Y? Hmm. Okay, let's have a look at the documentation. Not to the React Native gesture handler. When a finger is placed, okay. Active offset range along X. Where fingers travel without activation. Okay. Average enable. On callbacks, on begin, on start, set the callback that is being called when given gesture handler starts receiving touches. The handler is not yet in active state. On start, set the callback that is being called when the gesture is recognized by the handler and it transitions to the active state. Okay, on end, on finalize. Translation X. Translation of point gesture along y-axis accumulated over the time of a gesture. The value is expressed in the point units. X coordinate of a current position of a pointer finger or a leading pointer when there are multiple fingers placed relative to the view attached to the gesture detector. Relative to the view. Okay, that's the problem because it's relative to the view attached to gesture handler. So the Y position is relative to this view. That's why if I'm gonna do event.y here, we're gonna see initially it's probably a bit positive, and then once we move above, it becomes negative because it's relative to this red box. That's not exactly what we need. What developers are doing all day, reading docs. Yes, absolutely. Absolute Y coordinate of a current position of a pointer. The value is expressing, okay, it's recommended to use it instead of Y in case when the original view can be transformed as an effect of a gesture. Okay, let's see what's the difference between Y and absolute Y. Oh, I think this one is the screen position. Yeah, and if I'm gonna do absolute Y here, I think it should work. It should work. It's the way only I'm animating it. Absolute Y. And then using this absolute Y, I translate probably to minus Y value. No. Do I need to translate to negative? Yes, I need to translate to negative values. This one is positive values, and I think I have to translate to Y value minus height of a screen. And initially y value should be the height of a screen. Yes, 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 it works. And it disappeared. Why it moved so much to the top? Okay. Okay, I think my checks here. So we're not gonna work anymore with negative values. We're gonna work with positive values. So let's revert this to more than height. If it's more, no, if it's less than that, we should unlock. And if event velocity y, probably that's gonna be the same. So we move, when we unlock, we move it to 0. We move it to the top. And when we reset, we move it to the height. Now, let's check it out. And if I'm gonna scroll up, I'm gonna leave it here. It comes back down. There, it moves up. If I'm gonna do it fast, it's gonna move fast up. And the same with velocity should happen for the reset, because if the velocity is very fast down, we need to reset it. Well, I'm gonna do them in separate if statements because that's gonna make a bit easier. If event dot velocity y is more than 500, then we need to, well, this is else if then we need to actually unlock, no, to reset. Here is unlock. I can make them into functions, but I will put them like this. Unlock, reset, unlock, reset. So now if I'm gonna scroll fast down, it's gonna work. Yes, yes. It's so good. Now I can finally remove red background, and our gesture handlers for the lock and unlock are working properly. Sweet, amazing. Height minus value. Yeah, thank you very much, Andrew. I think that's what I ended up with. I will. So on start event, we don't even need it. Yes. Okay, so so that's how you implement gesture handler in your application in order to drive some swiping animations. For example, in this application that we are building here, where we are trying to reproduce iOS lock screen, we implemented the gesture handler to unlock the screen. So as you can see, we are the gesture handler only works on the bottom part here, because if we scroll in the middle part, we're gonna scroll the flat list. But if we're gonna drag from the bottom, our lock screen follows our finger, and if we release it here on the top, it will unlock the screen. If we release it to the bottom half, it will reset it back here. But we also implemented some checks for velocity, because if we swipe up very fast, then it will unlock, and that's how it works on iOS. And the same thing for unlocking. Like if I swipe from the top of a screen down very fast, then our screen will unlock. Not, our screen will lock. We're gonna see this lock screen. So All right, so check the next video where we will implement some more animations, specifically with blur background, depending on our gesture and depending on the position of our scroll animation. If you enjoy this video, subscribe to the channel and let us know what other animations you would like us to see build in the future. Okay, so now we can move on to the last part of this tutorial. And this is going to be the continuation for our blur background. Right now, let me double check if it didn't leave any console logs or stuff like that. I think we're good. This transform, I don't need it because this one is animated. Yeah. Let me add everything here. Gesture handler. And yeah, as I said, the last step is to work a bit with blur background. It's happening. Everything good here. Oh my god. Oh, no, I needed that transform. Sorry. Yeah. Let me... All right. So now, okay. Now what we want to do is to blur the background of this lock screen depending on how far are we from unlocking the phone. This can be very easily seen in the actual iOS lock screen. So if I'm gonna drag it from the top, what you see here is the actual lock screen from iOS. And as you can see at the top, like it's pretty blurred, but as we move down, the background image becomes more vivid and we can see it properly. So let's do that same in our application. So for that, we have this shared value y that represents the position of our lock screen on the y axis. Based on this y-axis, we will drive animation for our blurred background. The problem is that in this situation, yeah, let's start first of all by defining this blur background, and then we're gonna think about animating it. So for that, we're gonna import the blur view from Expo blur, and we're going to wrap. What are we going to wrap with this blur view? We need this image background to be blurred and everything inside it, for example, the notification list, not to be blurred. So let's try to put our blur view inside the image background. And let's close it before closing the image background here. I can close it even, but yeah, it's okay. And now if I'm going to play with the intensity, for example, if I say 0, our background is fully visible here. And if I'm gonna say 100, our background is going to be fully blurred. So this is how we have to work with this blur view. But let's do the same with the home screen, because the home screen should also be blurred. As you can see here, I don't think you will be able to see it, but in iOS 16, like both the home screen, both the things that are behind and in front, they're both blurring, but yeah, they change basically intensity. One is increasing, one is decreasing. So let's go ahead and add a blur for the whole animated lock screen. I think that one is going to be let's think about it. Maybe I can add it like a blur view here with some position absolute. Position style. Let's do the same style as that one, but in this case, yeah, intensity 100. Yeah, it will work. Yeah, perfect. And if I decrease the intensity here to 50, yes, it works. So what we have to do is whenever this blur view is 0, basically whenever we see the home screen, this blur view of the background image here should be 100, and vice versa. When the home screen is not visible, this one should be fully visible, and now our home screen, the home screen is blurred. So let's define the animations for this intensity. But the problem is that, as you can see, what we want to animate now is not the style of our blur view, but it's actually a property of a component. With Reanimated, we can also animate properties using instead of use animated style, we're gonna work with a use animated prop. This will give us the ability to animate properties of a component. Now, the second problem is that whenever we are working with animated styles or animated property, the component that we are applying the animation should be an animated component. So this one is an animated view, as you can see, because if it was a simple view, we would not be able to animate it. The thing is that with custom component, we do not have animated .blur view, of course, because animated will only contains the most common components that we can animate. But the good thing is that we can create an animated custom component. To do that, it's pretty easy. So we will define it here on the top. Animated blur view is going to be equal to animated dot create animated component, and we're going to pass here the component that we want to make animated. Now, this animated blur view now can expect like the animated properties that we talked about. Let's go ahead and replace the blur view here with the animated blur view, and blur view here as well with animated blur view. Now everything is fine, and the next step would be to animate this property. So as I said, we're gonna work with animated properties. So let's go ahead and define the let's do background, or let's do home screen blur equal use animated prop. And in the use animated prop, we need an object or a function. Yeah, it's a function. We need a function that will create our animated properties. So what is the property that we want to animate? It's called intensity. Let's put it here in our object, and let's specify how we want to animate it. Well, we're gonna interpolate the value of our y value. So we remember that y value goes from 0 to the height of our screen. So for the home screen blur, when we are at 0, 0 means that we are all the way up. All the way up, home screen should have 0 blur, but when the lock screen is all the way down, basically when it matches the height, then our intensity for the home screen blur should be 100. Let's copy paste this one more time for the lock screen, because here we will reverse these values. Here is 100, here is 0. Now let's go ahead and send these properties to our animated views. So instead of specifying the intensity here directly, we're gonna say animated props equal to home screen, how is it? Home screen blur. And for the other one, animated blur here, instead of intensity, I'm gonna do animated props equal not home screen, but lock screen blur. Now we see that the lock screen here is fully visible. There is no blur. Let's try to drag this to the top. And as more we move to the top, you see, actually, let me go ahead and uncomment this notification list because it's messing up with something here. Will it work? I need to just display a view with hide auto. Okay, I'm gonna leave them here, but it's gonna be a bit more difficult to see it on the screen. So let me refresh. What's happening with our footer? The footer is being pushed by something, but I don't know what is pushing it. Is it because of this one that we just added? Hey, what's up with the footer? Punch gesture. This is our footer. Are you being pushed by this one? Oh, I think I know. Styles. I'm gonna do again styles.container here. It must be pushing. Animated blur view. Give me 1 second to debug this issue. Background color red. Animated blur view. Because if I comment this out, yeah, everything is okay. You know what? I think I can do similar way as we did for the previous one, not to wrap everything in this animated root view, but to make it as basically absolute fill, like this. And now if I'm going to unlock, the gesture handler is also commented out. So now let's give it a try. I'm going to refresh. And now as we will start slowly unlocking the phone, we see that the home screen becomes unblurred, and the same things happens when we lock the phone. As we move down, not here, but this one, as we move down, we see the home screen blurring more and more, and our foreground here is actually fully visible. And the same things happens for the background of our lock screen. As we start unlocking, it starts fading away, and we start revealing the content behind. Oh my God, that's amazing. That's actually everything that I wanted to show you today, and I'm happy that we are actually in time. So that's how you work with blur views and how we also animate them based on the gesture and based on the gesture handler that the user is doing here in the application. Oh, that was intense. So, guys, do you have any questions? Because I'm going to add everything. This is animated blur view. And I'm going to push all the changes to GitHub, and you can find the source code in the description below. Fail to push because there must be some changes there. What happened there? I love it so much. What other features do we need to implement here in order to be like one-on-one mapping with an iOS device? What things do you see that it's different from how iOS 16 lock screen works? I really want to see it on my phone. Oh, there is some merge conflicts. Haven't seen them. Yes, we are done. Not gonna lie, that's actually sick. Thank you very much. Let me, as I said, I want to feel it in my hands. Let me scan it here. We did a lot of interesting things today. Come on, restart. Oh yeah, baby. Oh yeah, looks so good. There is some warnings, excessive number of pending callbacks. Some pending callbacks that you might have leaked by never being called from native code. Okay, something interesting to debug later. Request entity too large, maybe. All right, guys. So thank you very much for being here with me till the end. I hope you enjoy this way of doing our live streams where we are covering multiple topics, very interesting topics of the same general application. And yeah, I'm pretty happy with how it turned out, specifically these animations, like they are crazy. And maybe we will have like more animations tutorials on the channel. Let me know if you enjoy these videos, and let me know what other tutorials would you like us to do in the near future. As always, if you enjoy this tutorial, make sure to subscribe to the channel not to miss any future videos. And till the next time, we are going live every Friday at the same time. So make sure to also smash that bell icon in order to be notified when we are live. Okay, so that was it for today, guys. Thank you very much, and I will see you next week.